We are continuing with the exercises on geometric sequences, and I think after a couple of more intense problems, these should feel a little bit more straightforward. We're on exercise number 5. If the first term of a geometric sequence is 3 and the common ratio is 0.2, find the fifth term. So what we know is we know that A1 is equal to 3, R is equal to 0.2. So if we write down that general formula, AN is A1 times R to the n minus 1. AN is equal to 3 times 0.2 to the n minus 1. You can put parentheses if that makes it easier for you to read or look at. So we're able to write down the general formula for this sequence pretty easily. And we want a sub 5. We want a sub 5, which is going to be 3 times 0.2 to the 5 minus 1, or 3 times 0.2 to the 4th power. Let's pull out our calculator. 0.2 to the 4th power times 3. And I'm just going to write this in decimal form. I have 0.0048, and that's it. By the way, we didn't really have to use the formula for this one. We could have just taken that first term times 0.2 times 0.2 again times 0.2 again times 0.2 again. I mean, that's exactly what the formula gave us, but not too hard to write down the general formula there anyway. So exercise 6, find a formula for the geometric sequence. Here we have to find the formula that's given by this list. And so, well, we can see right away A1 is equal to 1, and we need to figure out what R is. And we can say R is what you multiply by to get from one term to the next. Here, because we're starting with 1 times a half is a half, so we don't even have to divide. We could, if we went backwards, a half divided by 1 is a half gives us the same thing. And just notice as we go down the line, times a half, times a half, times a half, 1/8 times a half is a 16th. So I mean, they're telling us it's a geometric sequence, so I assume we got to get the same number each time. We'd better. So what we see here is R is equal to a half. So that general formula is going to take this form. AN is equal to 1 times 1/2 to the n minus 1. Sometimes in this situation, just like a 1 coefficient isn't written, you could also just write your answer as 1/2 to the n minus 1 with that 1 understood. Okay, one more problem here. Find a formula for the geometric sequence given right here. Well, we know what A1 is. A1 is negative 3,000. Now here I'm saying, what do I multiply negative 3,000 by to get 300? I could just take 300 divided by negative 3,000 to figure that out, and it looks like I'm going to get negative 3 with negative 1/10, right, when I reduce that fraction, or negative 0.1 if you prefer a decimal. So R is equal to negative 1/10. And let's just kind of verify that down the line. If we take negative 1/10 of 300, I'm going to get negative 30. If I multiply by negative 1/10, again, a negative times a negative is positive, I'll get positive 3. and then a positive times a negative 1/10, 3 times negative 1/10 gives me negative 0.3. When r is negative, you tend to see this alternating between a positive and negative value as you multiply down the line by a negative. When r is positive, of course, you'll get all positive values or all negative values if a1 is a negative. So here r is negative, and so our general form, an equals a1 times r to the n minus 1. An is equal to negative 3,000 times negative 1/10 to the n minus 1. And again, that negative 1/10 could be written as a negative 0.1 decimal, would be just fine. So there we got it. And that's the end of the geometric sequence set of videos.